Sorry, sir. I was studying and I lost it.
Actually, you join on time, but Kanishka is usually late. Acha, tell me, did you watch the last class recording, that Carnot cycle?
I watched till no, sir.
Do
A
you
little
want?
bit.
Okay. Let me explain it once again. The Carnot engine is a what is Carnot engine? Carnot engine is an engine which is supposed to have the maximum efficiency. Actually there are engines which are present. Actually, we see in our daily life, we see in cars, trucks, and all. Na? There we see everywhere engines are present. Diesel engine, petrol engine, like that. Now, for every engine, there is an efficiency. Means few engines actually they work on higher efficiency. Few engines they work on lower efficiency. What do we mean by efficiency? Means the power output. Means the amount of input you are giving and the output that's getting produced, because some of the energy is being lost. Okay. Now here in the engine, how do we calculate the efficiency of an engine? Efficiency of an engine is given by the total work which is done in the cycle. This the engine, the processes of the first, let me tell you, the processes which are present in an engine, actually they complete one cycle. They start from one point and they again reach to that. How? Suppose you take an example of 4-stroke engine which is present in the writing left. 4-stroke engine is actually present in our bicycle, the motorcycles and all, motorcycle, car, like that. What are these 4 strokes actually mean? The 4 strokes means they represent the 4 parts of a cycle. Why? The piston. This is a piston. It moves down, sucks the air mixture. This is the first part. Then it moves up, compresses. Then again it moves down. And then again it goes up where the exhaust is there. So it started from the top point and again it completed one cycle. Again this cycle gets repeated. Getting my point? This actually you will learn in the later classes when you actually, if you take mechanical engineering as your branch, if you opt for that, you will learn about this, what is a cycle. But for now, you just understand an engine actually operates in a cycle. Means from the point from where it starts, it has to reach again after a certain point, a certain time interval, it should reach to the initial point. And then again repeat itself. So in an engine, in an efficiency, the efficiency of an engine is given by the total work done in the cycle divided by the heat absorbed. Now, I have taken this example on the right. Suppose this is a cycle in which there will be work done. Suppose this work, W1 is the work done on the cycle, on the engine, and W2 is the work done by the engine. Q1 is the heat absorbed in the engine. Q2 is the heat released from the engine. Now, according to this, efficiency is total work done by Q1. Now, total work done in a cycle by heat absorbed, you see this every cycle or every process actually it follows the first law of thermodynamics. And we know in a cycle, the total internal energy change is 0. Because it is starting from a point and again reaching to that point only, and the internal energy is actually a point function. So the delta U will be 0. So delta Q is equal to delta W. So we can easily write total work done is equal to Q1 minus Q2. total heat absorbed. Q1 is the heat absorbed, Q2 is the heat lost. So net heat which is present in the system is Q1 minus Q2. Understood? Haripriya, this one?
Yes.
Hmm. So now the efficiency of an engine is given by this formula, this bracket. Efficiency is equal to total work done divided by Q1, which is heat absorbed, is equal to, since we have found W net is equal to Q1 minus Q2, Q1 minus Q2 by Q1, or you can write simply efficiency as 1 minus Q2 by Q1, where Q2 is the heat released by the cycle and Q1 is the heat absorbed by the cycle. This is the formula you will be following. So coming to our Carnot cycle. Carnot cycle is supposed to have the higher efficiency, maximum efficiency that is achievable. Now, what are the it is supposed to be a cycle. It is again a cycle, but what are the four different processes involved in the Carnot cycle? The four different processes are 1 to 2 is a isothermal process. Look carefully. 1 to 2 is an isothermal process. 2 to 3, actually I'll tell you in short. 1 to 2 cycle is going like this: 1, 2, 2 to 3, 3 to 4, and again 4 to 1. Clear? Like this it is going. Now in this, what they have given, the what processes are process 1 to 2, process 1 to 2 and 3 to 4. They are isothermal process, meaning temperature is constant. And I have assumed the constant temperature in the process 1 to 2 is T1 and the constant temperature in the process 3 to 4 is T2. Clear? Kanishka, actually I'm explaining this Carnot cycle again. Now 1 to 2 and 3 to 4 are done. The process 2 to 3 and 4 to 1, they both are adiabatic process. Adiabatic process means no heat lost or heat gained. Heat exchange does not take place. So two processes are adiabatic, that is 2 to 3 and 4 to 1. And other two processes 1 to 2 and the 3 to 4 are isothermal process. I have represented temperatures for each 1 to 2 and 3 to 4 also, T1 and T2. Now finding out the efficiency. Now the first question that I asked to Kanishka in that class, the same question I'll ask to you also. You know the four processes and you have actually learned about these processes also. Look, you know the process 4 to 1 and 2 to 3 are adiabatic process, so no heat exchange take place. Now can you tell me by your own calculation, your own knowledge, which of the process 1 to 2 or 3 to 4 will absorb heat and which process will lose heat, and why? I want the reason, because I have given the process 1 to 2 will absorb heat and 3 to 4 will lose heat, but why? What's the reason
So
for it?
expansion and compression. It's like
So in the process 1 to 2 is expansion going on. So how can we
so
determine?
heat will be absorbed from the.
Acha. But it does not always mean like that, na? If heat is being absorbed, temperature is constant, volume is increasing. Okay, like that also you can think. Easy one. It's practical. This practical observation will work here. And again, in the process 3 to 4, volume is decreasing means heat should be lost. Yes. Hmm. But again, you cannot think like this because pressure is also changing, na? Yes, Haripriya? Pressure is also changing, na? What's the other way to analyze? Why process 1, 2 will absorb heat? See, I can say like this, 1 to 2, even though volume is increasing, but pressure is also decreasing. So why should absorb heat only? If pressure is decreasing, volume is increasing. Then also your thinking is correct actually. Pressure decreasing, volume increasing. Hmm. But temperature is constant. Acha, tell me other way. Can you do by using your normal theoretical calculation that we have learned? By using that, can you think? It's an isothermal process. In an
So
isothermal process,
like the internal energy would be zero, hence the work done will be the heat produced or absorbed.
that's correct. But from that also, how will you find out that delta Q is positive?
So you'll get during expansion, it's usually work done as positive, so you'll get energy.
Actually, the work done formula in an isothermal process is given by nRT log V2 by V1. Yes, we have derived that formula, no? nRT log V2 by V1 in an isothermal process. Now, when volume is expanding, increasing, so the log value will be positive, right? 1 to 2. Where I've done the calculation? Where is that? Oh, I've not done it. See, if you go in the process 1 to 2, I'm doing left, writing here. If you do 1 to 2, dq is equal to dw, which is equal to nr t1 log ln v2 by v1. Since v2 is greater than v1, yes, this part will be positive. So delta w is positive. So delta q is positive. When delta q is positive, that means heat is being absorbed. Correct? Yes. In the same way, if you go for 3 to 4, again from 3 to 4 process, you will apply that formula. nRT2 log V4 by V3. But V4 is actually less than V3. Correct? So the delta Q that you will be getting is log value you will be getting is negative. So here I have done. See here. Here I have done the calculation. That's what I was thinking. I have shown. 1 to 2 calculation I have done. So 3 to 4, again it will be negative because 4 is less than 3. Right? Here. For 3 to 4, nRT to log V4 by V3. V3 is greater than V4, so I'll take the negative outside. Delta Q is lost. Here are the calculation. This right one and left one. I've done it. Okay, understood? Now calculating the efficiency. Efficiency is given by 1 minus Q2 by Q1. Q2 is the heat lost and Q1 is the heat absorbed. So I have just written the formula. Q2 is nRT2 log V3 by V4. Q1 is nRT1 log V2 by V3. Why I have written V3 by V4? You'll ask, sir, V4 by V3 should be written now. Q2 is negative. We have found the negative value of Q2 comes when we bring V3 at the top. So that's the value of the heat lost. Otherwise, it will be considered as heat absorbed. Yes, Haripriya, see properly.
It's like we remove the negative log.
We have removed the negative part. So to understand that Q2 is lost, then that part, the magnitude part, will write here Q2. And then NR will cancel. T2 by T1 log V3 by V4 log V2 by V1 will be remaining. Now again, I can cancel them. V3 by V4 is equal to V2 by V1. Why? That I have derived by using the property of adiabatic process. 1 to 2 is adiabatic process. I can write T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1. But T1 and T2 are same because at 1 and 2, both points, temperature is same, T1 only. So like the T1 V2 power gamma minus 1 is equal to T2 V3 power gamma. Okay. I have actually applied from 2 to 3. I have applied adiabatic process equation from 2 to 3. At point 2, the temperature is T1. T1 V2 power gamma minus 1. At point 3, the temperature is T2. T2 V3 power gamma minus 1. Again, from 4 to 1 because that process is also adiabatic. T2 V4 power gamma minus 1 is equal to T1 V1 power gamma minus 1. This is the equation that I have written here. You want to see? See? This and this. Now, why I have done this? To find out the relation between V1, V2, V3, V4 by eliminating T1 and T2 by dividing both equations. Okay, shall I move forward?
Yes.
Okay, now see, because by dividing these two equations 1 and 2, I'll get T1 and T2 will be T1 will be cancelled, T2 will be cancelled. I'll get V2 by V1 power gamma minus 1 is equal to V3 by V4 power gamma minus 1. Means V2 by V1 is equal to V3 by V4. So that's why log V3 by V4 is equal to log V2 by V1. They will be cancelled. So I'll get the value of efficiency as 1 minus T2 by T1. That's why the efficiency of a Carnot cycle is 1 minus T2 by T1. Just remember, T2 is the temperature of the lower isothermal process. The thing that you have to remember. T2 is the temperature of the lower isothermal process. T1 is the temperature of upper isothermal process. Got it? Can I give you a question now?
Yes.
Today we'll do some questions and then I'll teach you about the second law of thermodynamics also, and then from the next class we'll start next topic. The next topic will be heat and mass transfer. Try this one.
So is it 8 kilojoule?
8 kilojoule. Wait, let me check. Hmm. Was it easy? Kanisha, you're getting the answer or not? Actually, very easy. It's no need to. 1 minus Q2 by Q1 is equal to efficiency is equal to W net by Q1. It is 1 minus T2 by T1. This formula you'll be using. So 2 into 10 power 3 divided by Q1 is equal to 1 minus T2 is 227, no? 300. 127 is 400. 2 into 10 power 3 by Q1. Oh, it was very easy. So Q1 is equal to 8 kilojoule. That's the solution. So this formula you'll be using. See, it was JEE main question. You solved it so easily. Give a next question to you. Try this.
So is it A? Yes.
Hey, yeah, let me check. Wait. No, A is not the answer.
I'm
B is.
getting efficiency is equal to 0.268. I
Cha,
mean 0.268, so percentage will be 26.8%.
what you are getting? 26 point?
8%.
26.8. No, if you approximate it, it will be 27, na?
So it's like C, and if it will be option C, it will not be equal to option D. So A, B, C, D are cancelled. The remaining option is here.
But they have given answer is what? Arey, where is the answer? Let me check the answer once again. What was your answer, Haripriya?
I told A.
A you told, na? Mm, B and C. No, no, no. Earlier, you told that the efficiency you're getting is 26.8. Correct? Do not approximate it. Your efficiency is 26.8, na? So correct. It is less than 27. So the correct options are either this one, D and B. So B and D. B and D only. B is the right answer.
We should not um, round it up.
No, 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 no. Did not round it off. Only to round because that's significant number actually. 26.8. It's a rounding of after point we can do. Like for 8, 3, 6, if it was like that, if it is given, we can round it off. But point, no one asked us to remove the point. Point 2 is a difference in efficiency. It's 20% different 20% efficiency change. What about you, Kanishka? You're getting answer? Efficiency less than the efficiency of Carnot engine, because I told efficiency of Carnot engine is maximum, and the efficiency is 1 minus T2 by T1, boiling and freezing point, 1 minus 273 by 373. So the efficiency you'll get is into 100, you'll get is 26.8%. This is the efficiency of Carnot engine. The efficiency of this given engine. Now solve this question, then I'll give you a good one. Acha, can you tell me if the efficiency is increased by 100% of the original efficiency, what will be the new efficiency of the engine? The original efficiency of was the 25%. The efficiency,
It would be like 125.
no, 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 it cannot be. Efficiency can never be more than 100%. You actually understood it wrong. I was actually, I knew you will get out here. The efficiency of 25% is given. He has told us efficiency, the new engine has increased the efficiency is increased by 100% of the original efficiency. Original efficiency was 25%. So 100% of the original efficiency means, again, efficiency was 25%. So the 25% increase is also there. So now the efficiency of the engine has become 50%. 25% plus 25% equal to 50%. Initially, the efficiency of engine was 25%. Now the efficiency of engine has become 50%. That's what they mean. Understood? This is where most students do mistake. Remember, efficiency can never be more than 100%. What happened? Are you able to solve it? See, let me solve it.
Yes, yes.
Initially, they have given the Carnot engine heat sink is at 27 degrees Celsius, means T2 is 27 degrees Celsius, meaning 300 Kelvin. So 1 minus T2 by T1, initially it is 25%, meaning 0.25, meaning 1 minus 300 by T1 is equal to 0.25. So it will become 0.75 is equal to 300 by T1. 3 by 4 is equal to 300 by T1, and I'll get T1 is equal to 400 Kelvin. Now what they have given, by how many degrees should the temperature of the source be changed to increase the efficiency by 100%. Now in the second case, 1 minus T2 by T1 has become 50%, meaning 0.50. Now sink is 300 only. Now what, let the new temperature is T1 dash equal to 0.50. So 0.5 is equal to 300 by T1 dash. So T1 dash is equal to 300 by 5 into 10, 600 Kelvin. So by what temperature has increased? Temperature of the source has increased. Delta T is equal to T1 dash minus T1. It's 600 minus 400. That's 200 Kelvin. So by 200 Kelvin, or you can say 200 degrees Celsius also. Not even, it won't change, because T1 dash, if you want to convert into degrees Celsius, minus 273 will be there. T1 again minus 273 degree, minus 273 will be there. And again, when you're minusing them, they both will be cancelled. So either the answer can be 200 Kelvin difference or 200 degree difference. Not a problem. So the answer is B. Tell me, you understood or not?
Yes.
Acha. Now let me teach you about, we'll solve some more question, but before that, let me teach you about the second law of thermodynamics. Hmm. See, the second law of thermodynamics. The second law of thermodynamics actually deals with the entropy. So what is entropy? You need to understand. Entropy is actually the degree of disorderness. Degree of disorderness. When they say disorderness is more, entropy is high. When disorderness is less, entropy is low. Okay, understand? more the disorderedness or the more the randomness, more is the entropy. Like that it is. Actually, when we talk about the entropy of the universe, it is actually increasing. It should be greater than zero, because as the universe is expanding, the disorderedness is actually increasing. Okay. Now there is an equation that you will be using sometimes. Gibbs-Helmholtz equation it is known as. That actually relates delta G is equal with this delta G is equal to delta H minus T delta S. Delta G is Gibbs function that you will be learning in chemistry. Delta H is enthalpy, again chemistry term. Delta S is the entropy. Just to make you familiar, I have given this equation. Now, how to calculate this entropy? To calculate the entropy, they have given the formula that this delta S is equal to Q reversible by T. Do you know what is a reversible process, Haripriya or Kanishka?
Yes.
I think and I think either you or Kanishka, someone has told me the answer earlier. The reversible process is actually so slow. The process is so slow that you will not be able to find out the change, actually, the change in the process. Delta is Q reversible by T. And in each process, you actually know how to find out the delta Q. Like if I talk about the constant pressure isobaric process or the isothermal process or the some other process like adiabatic process, in every process we know how to find out the delta Q. So just put that value of delta Q and then divide by T, the constant temperature, you will be able to find out the entropy. Like if we talk about isothermal process, Q reversible is nRT log V2 by V1 divided by T. So the entropy will be nR log V2 by V1. You understood now how to calculate the entropy? It's that simple, nothing complex. Second law of thermodynamics actually deals with the entropy only. They've explained about the entropy. Entropy is the degree of disorderliness. So what they mean by delta S universe is greater than zero. Delta S universe is actually made up of system and surrounding. That means that the entropy of the system plus entropy of the surrounding is always greater than zero. That's the meaning. Understood? These were the things. If you want, I'll give you some questions, but before that, let me cover the topics. In the next class, I'll be starting the topic, one new topic, that's your heat and mass transfer. Okay.
Yes.
Okay.
Excuse me, sir.
Uh,
Sir, I need help with chemistry ionic equilibrium.
Acha. Okay. Okay, I'll teach you that one. No problem. Actually, I've taught the topic. If
Like I need it before 27th of Jan.
22nd of Jan.
7, 7, 7.
Tell me the date.
27th.
27th, na? I can do one thing. I'll
Yes.
do one thing. I'll share the recording of the ionic equilibrium.
Okay,
You
sir.
can watch it. If you still get doubts, you can send me. You can
Okay.
take. Okay. I know you will be able to understand the ionic equilibrium easily from that.
No,
I'll
sis. Like I know the concepts, but I'm not able to solve like the MCQs.
say you're not able to solve the MCQs.
Especially the pH part, the buffer solution, and the titration.
Acha. Just try to watch the recording. See if you are not able to solve the questions only. I'll take one class for you just to make you solve the question. You understood the formulas, no?
Yes, sir. No,
What?
sir. Like it's like all getting confused. Like I have thermochemistry, then have chemical equilibria, ionic equilibria, redox.
Mm.
Like it's all together.
See, I'll do one thing. You watch the recording first because I think you have confused. You have got confused. You watch the recording, you will be able to understand the concept because there actually uh, I have given the problems to solve also, like we do in here. I have given them, and still if you are not able to understand, not able to solve the questions, I'll take one class for you to solve the question. Okay, I'll
Sure, sir.
share the recordings. You'll understand it. It's easy.
Okay, sir. Thank you, sir.
Bye bye.
Bye.